Okay, guys, now that we know how to determine the slope of a line, we're going to take a look at what is called slope-intercept form, which is one way we can write an equation that represents a line. We will learn how to write a linear equation in slope-intercept form from a graph when we're given 2 points, and then how to graph functions using slope-intercept. Slope-intercept form is the formula. It is an equation that represents linear functions. Y equals mx plus b is slope-intercept. It is called slope-intercept form because we can easily identify the slope, which is represented with a variable m, and we can identify the y-intercept, which is represented with the variable b. Our slope, remember, is y2 minus y1 over x2 minus x1, and that is rise over run, the change of the y's compared to the change of the x's. The y-intercept is the point where our graph crosses on the y-axis. And so here is the y-axis, this is the x-axis, and if we had a line such as this, the point here is called the y-intercept. It is where the graph, our linear graph, crosses the y-axis. We write this as an ordered pair, 0, comma, and whatever. Let's say that is 1. So that would be the intercept 0, comma 1, where 1 would be the b value. So let's go through some of these and let's take a look. So here we have our equation. It is in slope-intercept form. Again, m, the coefficient of x, is the slope, and the constant is our y-intercept, our b value. So in this case, our b value is -1. Now remember, slope-intercept form is when the y is isolated, when y is by itself. So here our slope is rise over run of up 3 and to the right 2. Our y-intercept is 0, comma, -1. Now our starting point is going to be the y-intercept. So we're going to start here, and then we're going to use the slope rise over run to locate other points on this line that's represented as y equals 3 over 2x minus 1. So we're going to go up 1, 2, 3, and to the right 1, 2. Up 1, 2, 3, and to the right 2. And we can keep going. And then a line passes through all of these points, and then it also extends down and left. Now, let me just show you guys how to locate points on the left side of the y-axis. So we have on the y-axis, and we have points to the right of the y-axis. In order to locate points on the left side, you go back to your initial value, 0, -1, and instead of going up 3, and right 2, we're going to totally go down 3 and left 2. So it's 1, 2, 3, left 1, 2. And you can see that lines up. Down 1, 2, 3, and left 2. And so this is our line, and we will put arrows on the end because this line is going forever to the right and up, and it's going forever down and left. So this is the equation y equals 3 over 2x minus 1. That is what that equation looks like when we graph it. Okay, let's take a look at a second example. It is in slope-intercept form. Our slope is -1 over 3. Notice the negative is out front, and I'm just going to take it up to the run, and this is going to say we're going to go down 1 into the right 3. Our y-intercept is 0, 2, and that's where we're going to start the initial value. So we're going to start at 0, 2, And then our slope is down 1 and to the right 1, 2, 3. Down 1 and to the right 1, 2, 3. And notice how the line is going downhill, and this negative slope told us this. Now, let's see what the points look like on the left side of the y-axis. So instead of down 1, right 3, we're going to go up 1, left 3, and up 1 and left 3. And see how the points just line up? This is our linear function, y equals negative 1 over 3x plus 2. We have an equation, and it is in slope-intercept form. Our slope is negative 2. Now, when I identify the slope and it's an integer and it is not in fraction form, we know that we can put a number over 1 to create a ratio. So we are going to go down 2 and write 1. And we're going to start at 0, negative 3. Our initial value is going to be 0, negative 3. That's the first point that we plot. Now we're going to go down 1, 2, into the right 1. Down 1, 2, into the right 1. To see what the points look like on the left side, we're going to start back at the initial value, our y-intercept, and instead of down and right, we're going to go up and left. So up 1, 2, left 1, up 1, 2, and left 1, up 1, 2, up 1, 2, and left 1, 1, 2, and there we go. And there's many infinite amount of points on this line, and we put arrows to show that it extends left and up and right and going down. Okay, now here is our next example, and it is in slope-intercept form. Notice that we don't have a value written for our slope, the variable m, so it's understood that there's a 1 there. So when we identify slope, we're going to say it's 1, and then we can put it over 1. So we're simply going up 1 and right 1. And we're going to start at 0, 4, our initial value. So we're going to graph 0, 4. Now we're going to go up 1 and right 1, up 1 and right 1, up 1 and right 1. Let's put a few points to the left of the y-axis by going down and left. So I'm going down 1, left 1, down 1, left 1, and so on. And it really only takes 2 points to make a line, but I like to plot a few. Okay, here we have y equals x. So, whoops, x plus b. So here is slope-intercept form. Again, this is an understood 1. So our slope, again, it's always the coefficient of the x. So it's going to be up 1 and right 1. Notice there's no value for b, so that is understood to be 0. When there's nothing there, we use the number 0 to represent nothing. So it's going through the origin at 0, 0. So that's our initial value. And then we're going up 1, right 1, up 1, right 1, and so on. Then we're going to go back to our initial value and go down 1, left 1, down 1, left 1, and so on. So our line looks like this. This is y equals x. Again, it's sloping upward because it has a positive slope. Okay, on this one, this is a unique line. We don't have an x. Y equals mx plus b. We do have the y-intercept 0, 4, because that's our constant. So really what happened was that our slope was 0 times x plus 4. But recall 0 times anything, even a variable, is nothing. So we really just have the y equals 4. So our slope is 0. So this is going to be the horizontal line. So it's going to pass through 0, 4. It's not going up or down. It's just continuously constant going through where y is 4. And all these little ordered pairs are like 1, 4. This one is 5, 4. Over here, we have -5, 4. So all these ordered pairs have a y value of 4, and it says y is 4. So the y has to be 4. So just remember that when you have y equals a constant, we have the horizontal line passing through that constant on the y-axis. It is the horizontal line, and it has a slope of 0. Now let's take a look at the vertical line. Remember, this is the equation. So our vertical line is passing through x at when x is 4 on this axis. This has an undefined slope, and I'm just going to put in A that there is no y-intercept. It's not going to pass through the y-axis. We could use the null symbol, and it is going to be this vertical line. And on all of these ordered pairs, the x has to be 4. Whoops. Here, this is 4, 0. Let's just pick one more just to show this. So this is 4, -3. So x is 4. Remember, x's, if they repeat and have different outcomes, this is not a function. Just to review that, it doesn't pass the vertical line test. So this is the vertical line. Okay, now let's take a look at a set where this is not in slope-intercept form. Y is not isolated. So we need to get rid of this term, this -2x. So we're going to move this term first before we undo the -4 times y. So we're going to add 2x to both sides. Notice I do not write my plus 2x under the 4 because these cannot be combined. I'm going to bring down -4 times y equals 4 plus 2x. Then we're going to divide every term by the -4 so that y is now isolated. And I have y equals -1, and this is a positive divided by a negative, so it's negative, and it simplifies to 1/2 x. So when we have a fraction as our coefficient of x, that's our slope, do not convert it to a decimal or a mixed number. So here we just have -1/2. Now I am going to move my x term in the front and move my constant to the back so it looks like y equals mx plus b. Now our slope is -1/2, so we're going to go down 1 into the right 2. Our starting point is 0, -1. So let's start at 0, -1, and then we're going to go down 1, right 2, down 1, right 2, and so forth. Now let's plot a few points on the left side of the y-axis. So instead of down 1 and right 2, we're going to go up 1 and left 2, up 1, left 2, up 1 and left 2. Again, we need to isolate the y, so it's y equals mx plus b, so we can easily identify the slope and the y-intercept. So this time we have a positive 3x, and we need to remove that from the left side, so we're going to subtract 3x. And we're going to bring down, this is -9 times y, and it equals -18 minus 3x. Now we're going to undo multiplication by division, and we're going to divide every term by -9. Y equals, we have a negative divided by negative, so that's +2. We have a negative divided by negative, so that's positive. That simplifies to 1/3 with our x, I'm going to rewrite it so the slope is in the front and our constant is in the back. So our slope is up 1 and right 3, starting at 0, 2. So we start at 0, 2, and we go up 1 and right 1, 2, 3, up 1 and right 1, 2, 3. Then we're going to go back to our initial value and we're going to go down 1 and left 1, 2, 3, down 1 and left 1, 2, 3. And then here is that equation. Y equals 1/3 x plus 2. I always like to write the y equals mx plus b for myself. Okay, so we're isolating y. Before we undo 4 times, we have to get rid of this 1x. So I'm going to subtract the 1x from both sides. I'm going to bring down positive for y equals -12 minus 1x. I'm going to divide every term by 4. -12 divided by 4 is -3. Minus, and there's an understood 1 here, so I'm going to write it like this, 1/4, and bring the x out to the side. I'm going to rearrange, so my -1/4 x is in front and the -3 is in the back. Our slope is -1/4, so it's going to be down 1 and right 4, starting at 0, -3. So we're going to go down 1 and right 1, 2, 3, 4. And if I go down 1 and right 4, it kind of would be about here. I'll go ahead and plot that. Then we're going to see what's on the left by reversing. Instead of down and right, we're going to go up and left. So up 1 and left 1, 2, 3, 4. Up 1 and left 1, 2, 3, about 4 here. And we have a negative slope, and that's why we see going from left to right, it is going downhill.